Hi, Algebra 2. We're going to do notes today online through a video because I want to do a mini conference with a lot of you today to get some stuff done individually. Please check out your notes now if you don't have them out already. The title in your notes today should be Polynomial Operations. Your goal today, so that your polynomial operations, should be in your table of contents. The goal today is I can add, subtract, and multiply polynomials. First of all, what is a polynomial? Well, I have the general form ax to the nth power plus bx to the mth power plus c. This could be any number. It could go on and on and on. You could have several terms. Each one of these right here is a term. So this one's 3 terms. When we have 3 terms, it's called a trinomial. 2 terms, it's a binomial. 1 term is a monomial. And many terms is a polynomial. Right here, A and B, these are called coefficients. And your coefficients can be fractions, and they can be fractions, they can be whole numbers. They cannot be irrational numbers, which should be anything like a square root. Right here, 1 second, let me just change my color a little bit. N and M are our exponents. These have to be whole numbers. They cannot be negative. They cannot be decimals. They cannot be fractions. And here, this is our constant. There's no variable with it. And you do not always have to have a constant in order to have a polynomial. The first problem I have right now is, and again, anytime throughout this, if you need to pause and write things down, you need to do that. The first problem I have here, example 1, I have a trinomial plus a trinomial, 3x cubed minus 4x squared plus 2, plus 5x squared minus 2x plus 1. And when we have adding polynomials, it's not too shabby. All we have to do is combine like terms. So I have 3x cubed, and I look through and I say, do I have any other x cubes in my problem? And I don't. So that goes down 3x cubed. Change the color again. Next, I'm going to say I have negative 4x squared. And I have a 5x squared. So together, a negative 4x squared plus a 5x squared gives me plus 1x squared. And you obviously don't need that 1. Just a placeholder if you like it. Next, I have a constant of a 2. And I have a constant of a 1. Now you'll notice, though, I have this right here, that negative 2x. In order to be in standard form, that really should come next, and I'll talk more about that in class. So minus 2x, and that doesn't go with anything. And then finally, let's do that last one, the constants. So oopsie, what did I just do? Sorry. The constants go right here. Plus 3. The constant should always go last, and I'll talk more about that in class. But for now, here's your answer. Sometimes it helps, I think, when you're dealing with it, to cross things off as you go. So 3x cubed, I was done with it once I wrote it down. Then the green, negative 4x squared plus 5x squared. I'm done with it. Then what do I have left? That can help sometimes if you need that for organization. Again, pause whenever you need to. I don't want to be going too fast. That's the beauty of the video. So you can pause it, re-listen to it, write down what you need. I have negative x cubed now, I have negative x squared minus 2x plus 3 minus 5x squared plus 2x minus 8. When we're subtracting, the first thing we need to do is distribute the negative. When we're distributing the negative, we are essentially changing the signs of the second polynomial. Okay, so we're writing that down. And my writing's never as neat on here, and I apologize. So when I distribute that, that changes this to a plus and this to a negative. This to a negative, so the plus goes away. And this to a plus. The signs have all changed. And now, and then remember, you only do it to the second polynomial. And now I'm just going to combine like terms. So I'm going to take it again. I'm going to, just like I did in the first problem, I'm going to try to color code it for you. Negative x squared goes with a negative 5x squared. Combining that, that gives me negative 6x squared. Okay, changing colors. Negative 2x goes with a negative 2x. That gives me a negative 4x. Crossing off. And then my constant of 3 goes with my constant of 8. And that gives me 11. And I'm done. So to summarize for us, when we have subtracting polynomials, I need to distribute that negative, and what that essentially does for us is it changes all the signs of the second polynomial, including that negative. It changes to a plus, and which enables us to combine like terms. Pause where you need, and I'm going to move on to the third problem. Now multiplying polynomials. You'll notice here we have a monomial times a trinomial. 1 term, 3 terms. When you have a monomial times a trinomial, all you have to do is distribute the monomial. Remember, when you are multiplying, you add exponents. If you need to, you don't have to. You can put a 1 here and a 1 here to help you. So I have 3x times 4x squared. That gives me 12x cubed because I'm adding those exponents. 3x times 2x gives me 6x squared. Again, adding those exponents. And then 3x times negative 1 gives me negative 3x. And that's it. For a monomial times a trinomial, just distribute that monomial to all the terms in the trinomial or polynomial, binomial, whatever it is. The important piece is that monomial. Whenever you're multiplying a polynomial times a monomial, just distribute it. It's easiest that way, in my opinion. Next, I have a binomial times a binomial. 2x minus 1 times 3x plus 1. I think you guys have been taught this before in the middle school by making the box. Forgive me. I was about to make a box for a trinomial. I have a 2 term times a 2 term. So I need a 2 by 2 box. I put my 2x minus 1 here and my 3x plus 1 here. It doesn't matter though. Remember, multiplying, we add exponents. So if you want to put an exponent there, just to remind yourself, you can do that. 3x times 2x gives me 6x squared. 3x times negative 1 gives me negative 3x. 1 times 2x gives me 2x. And 1 times negative 1 gives me negative 1. Step 1, we do the box. Step 2, we combine like terms. So I have 6x squared. I used it. Nothing goes with it. I have 2x and negative 3x together. That gives me negative x. And then I have negative 1. And I'm done. Here's a different way of looking at a binomial times a binomial. Oftentimes people want to distribute this. That is incorrect. Don't do that. That's against the law in math. When you see something that looks like this, you need to write it twice because the exponent's twice. X minus 2 times x minus 2. And now I want to show you something that's not the box, and you can elect to use this if you'd like. I'm going to take this term here and just distribute it. X times x is x squared. I'm going to distribute it again, minus 2x. I distributed that term. Now I'm going to distribute this term. Negative 2 times x is negative 2x. Negative 2 times negative 2 is plus 4. And now I'm going to combine like terms. So we use the box or we distribute. You get to decide if you liked it like the first example with the box or the second example. I need to combine like terms still. X squared is by itself. Negative 2x and negative 2x is negative 4x plus 4. I went fast there. Slow down, pause when you need. I'm going to go on to the last problem I believe I have. I have a binomial times a trinomial. Again, make the box here. I have a 2 by 3, 2x plus 5, x squared plus 2x minus 1. So 2x times x squared gives me 2x cubed. Again, if you need to, write that exponent there. Oops, sorry. Give me a second, I'm changing my color. 2x squared times 2x. This gives me 4x squared because of that 1. 2x times negative 1 gives me negative 2x. 5 times x squared gives me 5x squared. 5 times 2x gives me 10x. 5 times negative 1 gives me negative 5. So I do the box, and you could do the distributive like we did on the last example if you wanted, distributing that all out, distributing it all out. If you elect to do it this way, though, we do the box first, then we combine like terms. It's getting messy, I'm sorry. 2x cubed goes first. Highest exponent always goes first in standard form. The next highest exponent is our x squared. We're combining like terms here. That means we're adding, so that's plus 9x squared. So don't make that mistake of multiplying. 10x and negative 2x. That gives me 8x and negative 5. All right, that's it. Pause, re-listen where you need to. I forgot I do have one last problem. It's a little more challenging, but you guys can handle it. It's a trinomial times a trinomial. Make a box on these. These get really messy if you use the distributive property. I have 3x squared plus x plus 1, 2x squared plus 4x minus 8. So 3x squared times 2x squared gives me 6x to the 4th. Remember, we're adding exponents when we multiply. 3x squared times 4x gives me 12x cubed. 3x squared times negative 8 gives me negative 24x squared, X times 2x squared gives me 2x cubed. X times 4x gives me 4x squared. X times negative 8 gives me negative 8x. 1 times 2x squared gives me 2x squared. 1 times 4x gives me 4x. 1 times negative 8 gives me negative 8. What I like about the box now, and I'm going to change my color again, is 6x to the 4th. Done. 12x cubed and 2x cubed in a diagonal there. It's just a little neater. And part of problem solving is being organized with your thoughts. So it gives you that framework. 12x cubed plus 2x cubed gives us 14x cubed. Whoa. $2x squared plus 4x squared minus 24x squared. So what is that going to give us? That's 6x squared minus 24x squared, which should give us negative 18x squared if I did my math right in my head, which I think I did. I'm done with it. 4x minus 8x gives us negative 4x. And then we finally have negative 8. Whoops, sorry, I did it in my highlighter. -8. And there I'm done. So I made my box, I combined my like terms, and I have it all right there. Again, the goal of today was I can add, subtract, and multiply using polynomial functions. I'll quick go through the slides of what we did as just little reminders for those of you who need it. Our goal, I can add, subtract, and multiply polynomials, polynomial operations. Reminding you what a polynomial is. Our coefficients can be fractions, or they can be, whole numbers or integers, negative numbers as well. Your exponents can only be whole numbers. And then you have a constant here. You don't always need a constant. When we're adding polynomials, we just combine like terms. Reminder, like terms, we don't do anything with the exponents. We just combine them. They stay. Subtracting, we take that subtraction sign, we distribute it to each term in the second polynomial right after it. That changes all the signs, and then we combine like terms. Multiplying any polynomial by a monomial, just distribute it. It's the easiest that way. Multiplying a binomial times a binomial, you can use a box. And then combine like terms. When you use the box, remember you're multiplying, and you need to add exponents. Then combine like terms. Or you can just distribute the terms like we did here. It's your call on how you want to approach it. We have a binomial times a trinomial. I would use a box here only for organization's sake. Remember again, when we're multiplying in the box, we add. Okay, so in the box here, we add our exponents when we're multiplying. But when we combine like terms, we do not add exponents. We just combine the terms that we have. And then we have our trinomial times our trinomial. Please work hard and let me know if you have any questions. Thanks, guys.